Common number patterns. Okay, gonna be quick about this. Numbers can have interesting patterns. Here we'll list the common patterns and how they are made. Okay, guys. So if we look at these sequences, guys, there is a relationship between the numbers for each of these sequences. Right. The first sequence has a difference of 3 between each number. 1 plus 3 is 4, 4 plus 3 is 7, 7 plus 3 is 10, 10 plus 3 is 13, and 13 plus 3 is 16, and it continues like that. So every time the sequence, guys, the numbers are increasing by 3. If we look at the second one, the sequence is a difference of 5 between each number. The pattern is continued by adding 5 to the last number each time. 3. From 3, now we come to 8. How do we come? So 8 minus 3 will be 5. So basically 3 plus 5 is 8. 8 plus 5 is 13, 13 plus 5 is 18, 18 plus 5 is 23, 23 plus 5 is 28. So every time we're going to say plus 5. Now this one here, the sequence has a factor of 2 between each number. So 2, 4, 8. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, times 2 is 32, times 2 is 64, times 2 is 128, times 2 is 256. Every time with timing the last number by 2. Okay, this last one, the sequence has a factor of 3 between each number. 3, 9, 27, 81, it continues like that. So 3 times 3 will be 9, times 3 will be 27, times 3 will be 81, times 3 will be 243, times 3 will be 729, times 3 will be 2187. So every time we multiply the last number by 3. Okay, let's look at the next. Okay, here we have the special sequences, right? And we have here 4 type of numbers, right? Triangular numbers, square numbers, cube numbers, Fibonacci numbers. Right, triangular numbers. The sequence is generated from a pattern of dots which form a triangle. By adding another row of dots and counting all the dots, we can find the next number of the sequence. Right? 1, 3, right, 6, 10, 15, 21, 28, 36, and 45. So we said this is generated from a pattern of dots which form a triangle. By adding another row of dots and counting all the dots, we can find the next number of the sequence, right? So as you can see, from 1 to 3, guys, it's increasing by what? I'm just going to show it here. Right, so what we basically mean is this. See here, plus 2, from here to 6 plus 3, from here plus 4 plus 5 plus 6 will be plus 7 plus 8 plus 9. So this right from here 1, so it's basically like this: 1, 2, right? And then it's going to be 1, 2, 3. Then it's going to be 1, 2, 3, 4. Then it's going to be 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Right, so it's basically, when you look at that, guys, when you draw it, it looks like a triangle. So every time, as you can see, the numbers are increasing, right? So how they're increasing, you see from 1 to 3, it's increasing by 2. From 3 to 6, now it's increasing by 3. From 6 to 10, it's increasing by 4. From 10 to 15 by 5. So every time the numbers that are increasing, so it's going to be more 1 more than previous number. Here it's increasing by 2, now it's increasing by 3. Here it's increasing by 4, by 5, by 6, 7, 8, 9, 10. Right, so when you write each row under one another, then you will get a triangular shape. Okay, that's why we call them triangular numbers. Now we have square numbers, right? So when you look at this, guys, so we get every number comes with a square. 1 to the power of 2 is 1. 2 to the power of 2 is 4. 3 to the power of 2 is 9. 4 to the power of 2 is 16. 5 to the power of 2 is 25. 6 to the power of 2 is 36. 4 and 7 to the power of 2 is 49. 8 to the power of 2 is 64. And then 9 to the power of 2 is 81. So every time we take in the next number, second power, which is going to be squared. That's why we call them square numbers. Cube numbers, every time we're going to take the next numbers, cube number. 1 to the power of 3 is 1. 2 to the power of 3 is 8. 3 to the power of 3 is 29. 4 to the power of, 1 to the power of 3. 2 to the power of 3, 3 to the power of 3, 4 to the power of 3 is 64. 5 to the power of 3 is 125. 6 to the power of 3, 2. 16, and it continues like that. So every time we take in the third power of, right, each number. Why we call it cube number? Because the third power, the power of 3, represents the cube numbers. That's why we call them cube number. Okay, we have the last one is Fibonacci numbers. Fibonacci numbers, the next number is found by adding the two numbers before it together. 0, okay, let me just show this rather. 0 plus 1 is 1. 1 plus 1 is, so 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8. 5 plus 8 is 13. 8 plus 13 is 21. 13 plus 21 is 34. So if I have to find the next number, guys, then how am I going to find the next number? I'm going to look at this, right? I'm going to say 21 plus 34, that is going to be, right, 55. So every time we adding previous numbers, we get the two previous numbers and we get the next number, right? These numbers are called Fibonacci numbers. So, right here, guys, we have that we're going to have to make a pattern and a conjecture. In mathematics, a conjecture is a mathematical statement which appears to be true but has not been formally proven to be true under the rules of mathematics. In other words, with a similar meaning to conjecture are hypothesis, theory, assumption, and premise. Make a conjecture about the next number based on the pattern, right? 2, 6, 11, 17. How do we make a conjecture about this? So if we look at from 2 to 6, right? 4, increasing by 4, increasing by 5. 6 plus 5 is 11. 11 plus 6 is 17, so it's increasing by 6. So the next number will increase by 7, right? So this is going to be 24, and this increasing by 7. So the next number will be increasing by 8. 24 plus 8 will be 32. The next number will increase by 9. 32 plus 9 will be, right, 41. Right. So the numbers increase by 4, 5, 6, and so on. Every time the amount of the numbers are increasing will increase by 1. So if the previous number is increased by 4, the next number will increase by 5. The next will increase by 6, the next will increase by 7, and it continues like that. So a sequence doesn't have to follow a pattern, but when it does, we can often write down a formula to calculate the nth term. Right. In the sequence 1, 4, 9, 16, 25. Where the sequence consists of the squares of integers, because 1 to the power of 2 is 1, 2 to the power of 2 is 4, 3 to the power of 2 is 9, 4 to the power of 2 is 16, 5 to the power of 2 is 25. Right, that's why we say this is a, right, square numbers. Right, the formula for the nth term is ntn equals to n square for this. Right, so if we look at here now, t1 equals to 1 square, so equals to 1, obviously. T1 means term 1, guys. T2 is term 2. Term 1 is 1. Term 2 is 4. 4 is what? 2 to the power of 2. Term 3 is 9. How did we get 9? 3 to the power of 2. Then that's how we get 9. Term 4 is what? 1, 2, 3, 4 is 16. How do we get 16? 4 to the power of 2. Term 5 is 25. How do you get 25? 5 to the power of 2. right? Therefore, we can generate a pattern, namely squares of integers. So next number will be 6 to the power of 2, next will be 7 to the power of 2, next will be 8 and 9, and it continues like that. So if the question asks me here, what is T10? The 10th term. So I'm going to say simply 10 to the power of 2, which will be 100. Okay. Let's clear this. Okay, if we look at here now, consider the following pattern. 1 to the power of 2 plus 1 equals to 2 to the power of 2 minus 2. Right, 1 to the power of 2 is 1, plus 1 is 2, equals to 2 to the power of 2 is 4, 4 minus 2 is 2. So it's giving me this. 2 to the power of 2 plus 2 equals to 3 to the power of 2 minus 3. 2 to the power of 2 is 4, plus 2 is 6. Right, we're going to say 6 equals to 3 to the power of 2, 9 minus 3 is 6. So when you work this out, it should give you this. Right, so we're going to say, if we have to add another two numbers, guys, so every time, as you can see, right, so another thing, okay, let's just do that. The next number will be 1, 2, 3, 4. So it's going to be 5 to the power of 2, right? Plus 5 equals to 6 to the power of 2 minus 6. Right, so if you do that, 5 to the power of 2 is 25, plus 5 is 7. 6, that equals to 6 to the power of 2, 36 minus 6. So 5 to the power of 2 is 25, plus 5 is 30. That equals to 6 to the power of 2, which is 36, minus 6 is 30. The next one will be, obviously, 6 to the power of 2 minus 6, plus 6 equals to 7 to the power of 2 minus 7. And it continues like that. Okay. So conjecture, screening, make a conjecture about this pattern, write your conjecture in Word. So we're going to say conjecture, squaring a number and adding the same number gives the same result as squaring the next number and subtracting that number. Okay, basically what we did just now. Generalize your conjecture for this pattern. How would you generalize it? We're going to say we have chosen to use n here. You could choose any letter to generalize the pattern. So n squared plus n equals to n plus 1 to the power of 2 minus n plus 1. So that is what we did here. So if your n is, say, 4, 4 to the power of 2 plus n is what? 4, equals to n plus 1. 4 plus 1 is 5. 5 to the power of 2 is 25, plus n plus 5, right? n plus 5, n plus 1 will be what? n is 4. 4 plus 1 will be 5. So we can see that's minus 5, right? As you can see. Right. The next number, okay. Now this one here. Write down the sum of the numbers in the fifth row. Let's look at here what's happening in the row. Show. Right, in this row here, okay. I look at this numbers how it's increasing. 5 plus 3 is, guys, it's 8. 1. This 11 plus 9, 20. This 27. Okay. 13 plus 15, 28. Plus 17 is 45. Plus 19 is 64. So basically, when I look at these numbers, I can actually figure out now what's happening here, because I can see that it's a cube number. You see 1 to the power of 3 is equals to 1. 2 to the power of 3 equals to 8. 3 to the power of 3 equals to 27. And 4 to the power of 3 equals to 64. So if you have to add another row here, obviously that row, because every time, as you can see how it's increasing, 1 to the power of 3, 2 to the power of 3, 3 to the power of 4 to the power of 3. So the next will be 5 to the power of 3. Right, the next row, first row will be 5 to the power of 3, which is going to be 125. So calculate the formula for the sum of the numbers in the nth row. Right, sum of the numbers will be, and in nth row is going to be n cubed, because right, the first row is 1 to the power of 3. Second row is 2 to the power of 3, which is 8. The third one is 3 to the power of 3, which is 27. Fourth one is 4 to the power of 3, which is 64. The fifth one we said 5 to the power of 3, which is 125. So then if I ask for the sixth row, that is going to be 6 to the power of 3. That's why we're going to say our formula will be n cubed. Right, what is the sum of the numbers in n1 row? So that is going to be n1 is going to be n minus 1. So n1 is asked for this, guys. So the last here is 4, right? The 4 rows are here. So for the third row, it's going to be 4 minus 1, right? Which will be 3, and then 3 to the power of 3 will be 27. Okay, so right, we have two tables here. Two learners, Anna and Deepika, they did an investigation on number patterns. They managed to get the same results for T, but notice that the patterns they had arrived and looked different. So determine an algebraic formula for Anna's pattern. Right, Anna's pattern is this. Right. So n is 1. Right, here it's 3. 1 plus 2 is 3. So it's basically 1 times 1 plus 2. So yes, 2, n is 2. 2 times 2 is 4. 2 plus 2, n, because we're going to say n times n plus 2. N plus 2 is what? N is 2. 2 plus 2 is 4. Times 2 will be 8. 3 plus 2 is 5. Times 3 will be 15. 4 plus 4 is 8. And 4 plus, sorry, n plus 2, 4 plus 2 is 6, right? Times 4 will be 24. The Vickers pattern formula can be written as n squared plus 2n. So that is basically is this 1 squared plus 2 times 1. 2 squared plus 2 times 2. 2 squared is 4. 4 plus 2 times 2 is 4, 8. 3 squared, 3 cubed, 3 to the power 3 to the power of 3, right? And then which will be 9 times 2 times 2 times 3, that will be 6. 9 plus 6 will be 15. So this is wrong. It's actually supposed to be 3 to the power of 2, which will be 9, plus 2 to the 2 times 3 will be 6. 9 plus 6 will be 15. So this is not, get it wrong here. This is 3 to the power of 2, not 3. Because if it's 3 to the power of 2 will be cubed, not squared. So yeah, 4 to the power of 2 is 16. Plus 2 times 4 is 8. 8 plus 16 is 24. Okay. So basically that's how it is. Then we come here. Okay, so again here, just a formula. The linear sequence, guys, the linear sequence, as we discussed in class, we're going to look at the number pattern, how it increases and decreases. If it increases or decreases by the same amount each time, then it's called a linear sequence. If we look at the sequence here, 5, 8, from 5 to 8 plus 3. 8 plus 3 is 11. 11 plus 3 is 14. 14 plus 3 is 17. So this is a linear sequence. Why? Because every time the numbers are increasing by the same amount. That's why we call it a linear sequence, because linear sequence is this. We're going to look at our number pattern. If it increases or decreases by the same amount, then it is a linear sequence. And then as you can see, this is increasing by the same amount. That's why it is a linear sequence. Right, as you can see here, this is T2 minus T1 equals to 8 minus 5. As we said, T, guys, stands for term. So T2 means term 2 minus term 1. Term 2 is 8, term 1 is 5. 8 minus 5 is 3. T3 minus T2, term 3 minus term 2 is, right, term 3 is what? 1, 2, 3, 11. 11 minus term 2 is 8. 11 minus 8 is 3. So every time, as you can see, the difference is 3. Term 4 minus term 3, term 4 is 14 minus term 3 is 11. 14 minus 11 is 3. So every time the difference is 3, that's why we say this is a linear sequence. Okay. Then another thing, yet the property of this number pattern is T2 minus T1 equals to T3 minus T2. So because every time you take a number and you say minus the previous number equals to another number minus the previous number of that. So term 2 minus term 1, 8 minus 5 equals to 14 minus 11, because every time obviously the difference is going to be the same. That's why we can say this. To find the nth term, right, we're going to say T2 equals to A plus the T2 is what? 8. That equals to A is what? First term. D is what? Difference. Difference is 3. First term is 5. 5 plus 3 is 8. T3 equals to A plus D plus D. T3 is 11. A is what? The first term, which is 5. Plus D. D was what? The difference was 3. Plus 3 is 8. Plus, again, 3 is going to be 11. So, you can say that equals to A plus 2 times D. D was 3. So it's basically going to be this. Let me just write this. So it's 5. First term is 5 plus 2 times 3. That equals to 5 plus 6. And that equals to 11. 11 is what? 1, 2, 3. 11 is term 2. Right. So term form just continues like that. As you notice, the second term D is 1D, and the term 2D, and so on. So in the nth term, there will be a form n minus 1 times D. The general term for linear sequence is Tn equals to. Guys, this is very important. This is now what we're going to be dealing with. That's the general formula for linear sequence. Tn equals to A plus n minus 1 times D. A plus n minus 1 times D. So Tn is the nth term. If I ask you what is the fifth term, right? Right, so Tn is going to be what? T5, because the fifth term will be the term I'm looking for. A is what? A is term 1. So in this sequence, A is what? The term 1. The first term is 5. D is difference. We said the difference here every time it's 3. So the difference is 3. Right, so n equals to what? N is number of terms. Right, so this is the most important part. Like I said, you're gonna have to know this formula. There's no other way. When we find Tn, so it's basically when we say Tn now, don't get confused, just thinking of what is Tn. Tn, if you see here, 1, 2, 3, 4, 5. 5 terms given. If I ask you what is the 10th term, so then my Tn will be what? N is the term. So T10, I'm looking for the 10th term in the sequence. That means that. So I'm going to say, then what? A plus, A will be what? Say, okay, let me just do it rather. So if I ask, the question is this, right? What is the 10th term in this sequence? How do I find that? So I'm going to say that Tn is going to be T10 equals to, what's the formula? A plus 1. A is what? 5 plus n minus 1 times D. What is the difference? Right. So then this is going to be 1. N is what? N is number of the, N is what? Number of terms. So this is going to be 5 plus, right? 3 times n will be 3n, because this 3 is multiple, right? Multiplication minus 3. So it's going to be what? This is equals to what? If you work it out, Tn, 5 minus 3 will be 2. 3n plus 2. Okay, now, because that I said, right, n is 10. I'm looking for the 10 number, 3n plus 2, right? So it's going to be 3 times n with what? I'm looking for the 10th term, so 3 times n will be 30 plus 2 equals to 32. Okay, let's see if it's really 32. Let's just continue. Right, we said the 10th term, according to this formula, is supposed to be 32. Let's continue. Every time, and this sequence is increasing by 3. So 17 plus 3, the next number will be 20. The next number will be 23. The next will be 26. The next will be 29. The next will be 32. Every time is increasing by 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Correct. That's true. Right. So what we're going to do again, this is this, guys. This is the most important part of this. Just as the general formula, right? Tn is whatever term, right, is asked in the question. You're just going to put it here. In this question, I asked for the 10th term in the sequence. So I said Tn is going to be T10 equals to, then I put everything in the formula. A is what? The first term in the sequence, which is 5. 5 plus n minus 1, right? That is the unknown, times 3. So when you work this out, 3 times 1, 3 times n. It's going to be 5 plus 3 times n will be 3n, 3 times negative 1 will be negative 3. So that equals to, we work this out, 3n minus 3 plus 5 will be 2. So your formula is basically going to be 3n minus 2. And then you think now, what number you will ask? Tn was the 10. And so n, can you see here, n is number of term. So 3 times 10 will be 30, because n is 10 term, 30 plus 2 plus 2 is 32. Right? So the answer is going to be 32. All right, let's do next. Okay, again, the same thing. There's a similar question here. Right, so if we look at this question here, okay, find 1, 6, 11, 16, 21. So every time this sequence is increasing by 5. I'd say what is the next number in the sequence, because since it's increasing by 5 every time, the next one will be 21 plus 5, which will be 26. What is the next number? Okay, with the use variables to write an algebraic statement to generalize the pattern. Right, so then it's going to be, right, Tn equals to, right, A equals to T1, right, then D equals to 5, n equals to number of terms from the previous page. We should know this, right? So Tn equals to 5n minus 4, or Tn equals to A plus n minus 1 times D, or 1 plus n minus 1 times 5, right? That equals to 1 plus 5n minus 5, or we're going to say it's 5n minus 5, that's actually 5n minus 4, right? So if you work that out, that's going to be 5n minus 4, right? So it says, question 3 says, what will be the 100th term? Okay, the previous question with the 10th term, right? So we said Tn equals to what? Right. So in this one, since it's increasing by 5, so the 100th term is going to be, right, the final thing was this 5n minus 4. Okay, that is wrong. I'm just going to rewrite it. When you work all of this out, see this here. When you work this out, it's not 5n minus 5, it's 5n minus 4. 5n, negative 5 plus 1 is negative 4. So it's 5n minus 4. It says the 100th term, n is was what? N is number of the term. 100 term is 5 times 100, right, minus 4. 5 times 100 will be 500, minus 4, that equals to 496. Okay, then it's which term of the sequence is 96, and then it's going to be this Tn equals to 96, and is what? 5n minus 4 is, so since this is what I will be using in the formula for that, yeah, the result is given 5n minus 4 equals to 96. 5n will, this is just now just an equation, equals to 9, take this negative on that side, will be 100. Then divide both sides by 5, then n equals to 20. Okay, so sorted. All right, let's see next question. Okay, it's finished. Okay, that was it, and this is the end of story.